Okay, dear students, so let us see what are we supposed to do in this kind of a type. So I must tell you that this type is the most difficult type, and majority of the students are facing problem with trigonometry in mathematical induction. Why? Because the last part of this mathematical induction is computation. And the computation in trigonometric terms become really very difficult because you must remember all those formulas and you must be good with trigonometry to solve these equations. Now that is the biggest problem with these kind of questions. So let us now see what can we do in this. So the equation is written in front of you. So I'm just writing step number one. And for step number one, we just write n is equal to 1 and we see whether the proposal is correct or not. So this left hand side will become sine theta when n is equal to 1. And here, when n is equal to 1, what is it that we are getting? Cos of 2 theta divided by twice of sine theta. Now here, I will say that even students will be stuck at this step also. Why? Because they will not be able to prove it further, like, what is this? And then we remember that there is this double angle identity, which is cos 2 theta is equal to cos square theta minus sine square theta, or you can take in the terms of sine, it will be twice of sine square theta, because sine square theta plus cos square theta is equal to 1. We have substituted it here. Sorry for the bad throat. Okay, so this is the main formula which can be taken as this as well as this. So here we are choosing this equation and we can prove it to be correct. Now 1 minus twice of sine square theta divided by twice of sine theta, and it will come out to be sine square theta divided by twice of sine theta. This and this gets cancelled, and later on it is indeed coming out to be equal to sine theta. So this is how we have proved that our proposal is absolutely correct if we take n is equal to 1. Now the problem is, until unless you know this much of the trigonometry, you will not be able to proceed further. So learning that much of the trigonometry is important. And how can you do that? By making more practice of these kind of questions. That is the only method that you can do. Now, moving next now, we are moving to step number two, and step number two, as we all know, is the assumption that we are making. So it is sine theta plus sine of 3 theta and plus up to sine of 2n minus 1 theta is equal to 1 minus 2. Okay, we are going to substitute k instead of n. Yes, so this is how we write the complete equation. Okay, we have just substituted n is equal to k and we assumed that yes, fine, this series is equal to that thing. Assumption. So what is step number three now? Now we are going to substitute n is equal to k plus 1. So what are we going to do now? So it will be sine theta up to sine of 2k minus 1 theta up to this, plus there will be one more term, and one more term will be sine 2 into k plus 1 minus 1 into theta. So this is another term that is added into the series. This is the last term. So this will be equal to 1 minus cos of 2 k plus 1 theta divided by twice of sine theta. So we have just simply substituted k plus 1 in the in the place of n there. So now we have to prove this complete proposal that the left hand side is equal to right hand side. How are we going to do it? First step is complete this series will be substituted here. So I am substituting this complete assumption here. So I can rewrite the equation as 1 minus cos 2k theta divided by twice of sine theta plus sine of 2 into k plus 1 minus 1 into theta is equal to Okay, this divided by twice of sine theta. So now this is a big equation, and my dear students, I tell you, up to this, even then, some couple of students will be able to reach at this step without making clerical mistakes. But after it, it becomes even more difficult. So now we have to apply the complete trigonometry here to solve this equation. So the first hint is that 2 sine theta is the denominator. Why not to multiply 2 sine theta on both sides? So it will be 1 minus cos 2k theta plus. So twice of sine theta gets multiplied here with sine of 2k plus 2 minus 1. So 2k plus 1 into theta. And on the right hand side, there will be no denominator left. So it will be 1 minus cos of 2k plus 2 theta. I'm writing here now. So this one and this ones get cancelled. So we will keep on cancelling things out because that is the easiest method of proving left hand side is equal to right hand side. So now what can we do? So we keep it like this into sine of 2k plus 1 theta is equal to this this cos is taken to the other side. Because it is negative, it will become positive here, and this negative cos will remain as negative. So this is how we write it. Now there is a formula that we are going to apply. Now what is that? Just a moment, I have to rub it. Now you see. So there is this formula that is cos A minus cos B is equal to negative of twice of sine of A plus B divided by 2 into sine of A minus B divided by 2. And now I'm going to apply this formula to the right hand side, because on right hand side I have two cosines. This is cosine and this cosine. So how can I write it? So the left hand side is completely written like this, same. And now I am concentrating on the right hand side. So it will be minus 2 into sine of A plus B divided by 2. So it is twice of k theta plus this, twice of k theta plus 2 theta divided by 2, and also sine of 2k theta minus 2k theta minus 2k theta minus theta divided by 2. So this is it that I'm getting by applying that formula. So there is this negative sign here. Be very careful. Negative 2. So this 2 will be coming out. So these are 4k theta plus theta. So 2 is taken out. 2 and 2 gets cancelled. So I am getting 2k plus 1 into theta here. Okay. 2 is taken common like this. Okay. 2 and 2 gets cancelled out. So this sign is coming giving us a negative value now. This and this gets cancelled out. Minus 2 theta divided by 2. So 2 and 2 get cancelled. So it is sine of negative theta. So as it is the property of sine, no, that this negative sign will come out. So this negative and this negative gets cancelled out. So we are left with twice of sine of 2k plus 1 theta into sine of theta. And you can see right hand side is absolutely equal to the left hand side now. So hence we have proved. So it's proved. This complete equation is proved with the help of mathematical induction. But you see, it will not be easy if we are not good with trigonometry. So more is your practice, more are the formulas that you know from the chapter of trigonometry, better you become at this part. Otherwise, the principle of mathematical induction is really very easy. If you are getting some other question other than trigonometry, I believe you can do that. So this is Professor Varun. All the best.